Assalamualaikum and a very good morning everyone. So today we are going to discuss some examples on the first part of the fourth chapter, Laplace transform properties. Okay, let's read for the first question. Given a signal as in figure 1, which is a superposition between sawtooth, square wave and pulses. So the first part, you need to write the mathematical expression for xt in general form of the unit step function. So you need to write the equation in unit step function. So secondly, you need to find the Laplace transform xs, meaning that you get the equation in t in time domain, then you need to find the Laplace transform of xt. Okay, the first part of question 1, write the mathematical expression for xt using unit step function. So therefore we need to use step by step considering the t. So the first one, at t equal to 0, so you need to consider at t equal to 0, and then t equal to 1, t equal to 2, and also t equal to 3. So at t equal to 0, you can see that one vertical line pointing upwards, and at t equal to 0 as well, there's a slope pointing down. Okay, so let's write the equation for both signals. So at t equal to 0, you have one line in which the magnitude equal to 2, and then ut minus t naught. So your t naught in this case is 0. So the equation for the lines is 2ut, in which it's pointing up, so it's positive. Next, you have the one slope pointing down, so it's negative due to the negative direction. And then this is the gradient y over x, 2 over 1, and then t minus t naught. So your t naught is the position where the line begins. So it's t minus 0, ut minus 0. So the equation for the first slope is minus tu t. Okay, let's move on to t equal to 1. So at t equal to 1, you have one slope. So the line that connected at t equal to 1 at this point. So you have one slope pointing up to the left, and another one slope pointing upward as well to the right. So let's write the equation at t equal to 1. So you have the first slope, the green the green slope. So it's pointing upward, so it's positive. And then this is the gradient, 2 over 1, and t minus t naught, where the line begins. So the t naught in this case is 1, positive 1. So t minus positive 1, ut minus 1. So the equation for the first slope is 2t minus 1 ut minus 1. Let's write the equation for the slope on the right. So again, it's pointing outward, so it's positive. And then the gradient is 2 over 1 y over x, and then t minus 1 ut minus 1. So these are the slopes equation when t equal to 1. Next, move on to t equal to 2. So you'll notice there's one vertical line pointing downwards and another one slope pointing downward as well to the left. Okay, let's write the equation for this signal. So the first one, you have one line pointing downward, so that's why it is negative, and the magnitude is from 2 to -1, so the magnitude is 3. ut minus t naught, so the line cross at t equal to positive 2, so therefore the equation for this line is minus 3 ut minus 2. Okay, move on to the next slope, another slope that connected to t equal to 2. So it's pointing downward, so it's negative. The gradient is y over x, and then t minus t naught, the line begins at t minus 2, t minus positive 2. So the equation becomes t minus 2 ut minus 2. So these are the two equations at t equal to 2. Okay, move on to the next position. at t equal to 3, so you only have one vertical line connected at t equal to 3. Therefore, at t equal to 3, the equation is pointing outward, so it's positive. The magnitude is 1 ut minus 3. Okay, so to get the complete equation of xt, you need to sum them up. Therefore, your xt equal to this equation. Okay, let's look at the second part of question 1. Find the Laplace transform xs. So you have derived xt equation in the first part. So then you need to convert xt into xs. So you need to refer to the Laplace transform table. So from this equation, you may notice that you have, this is the fundamental shape. So from the table, you'll notice this. And then you have also tut function. So tut function, so this is tut function from the table. And then you have also shifting properties. Okay, so shifting properties given by this equation from the table. So you need to consider converting each of the components inside xt. So, okay, so this is the equation in time domain. So 2ut, okay, so in this case 2ut, so ut equal to 1 over s in s domain. So this is for this one. And then 2tut, so this one tut, so you know that the n equal to 1, therefore the n factorial, so n equal to 1 in this case, n equal to 1, so 1 factorial divided by s 1 plus 1 times 2, the magnitude. Okay, so this is for the second component. Move on to the next component. Again, you still have tut function, but there's shifting properties as well. So in this case, this is for tut. So t is still to the power of 1. So 1 factorial divided by s n plus 1. So 1 plus 1. So since there's shifting properties, ut minus a will be having multiplication by exponential function in S domain. So in this case, ut minus 1, therefore your a equal to 1. So in this case, your a equal to 1. Okay, next, move on to the fourth component. So it's more or less the same as the first one. Okay, next component, same as the third one, and this is also same as the first and the fourth component. Okay, once you have converted all components into S domain, so please simplify or finalize your final equation. Okay, now let's look at the second question. Given a function fs in S domain, so you need to determine 3 sub-questions. The first one, find the Laplace transform for gt equal to e minus 4t ft. And then another one, another function given as in the second part. And last one, you need to find the inverse Laplace transform of the given equation. Okay, let's look at the first part of question 2. So given the fs, find the Laplace transform for gt equal to e minus 4t ft. Therefore, you need to always refer to Laplace transform table in the first place. So you may notice that this equation is in the shape of this. Okay, therefore you can write the equation. So e negative at from the table, okay, from Laplace transform table, e minus at ft equal to, will produce fs plus a. So in your case, your gt is equal to e minus 4t ft, in which it produce fs plus, okay, since a here is 4. So you already have the fs equation given to you. Therefore, your gs equal to fs plus 4. So it is equal to s plus 4. So all s must be added by 4. So s plus 4 squared minus 7 s plus 4 plus 10. So this is your gs. So because the question asks you the Laplace transform of gt, so it is gs. Okay, next, the second question. Find the Laplace transform for ht equal to the given equation. So again, you need to refer to Laplace transform table. So look at the closest shape as the given equation. So therefore, from the table, you may notice there's time shifting operations. So in which ft minus t naught, ut minus t naught will produce fse minus st naught. Okay, so let's compare the given equation with the one in the table. So in this case, from the table, so you have ft minus t naught ut minus t naught that produce fse minus st naught. So now compare with the equation you have. So it's so this is ht. So ht equal to ft minus 5 ut minus 5. So in which you know that your t naught is equal to positive 5. Therefore, your equation fse minus s, so your t naught is positive 5. So therefore, the Laplace transform of ht is hs. So it is hs is equal to fs multiplied with e minus 5s, in which it is equal to your fs as given, so s divided by s squared minus 7s plus 10 multiply with e minus 5s. So this is your hs, or the Laplace transform of ht. Okay, question 2, part 3. Find the inverse Laplace transform of fs. So you need to find ft by using inverse Laplace transform. Okay, so usually in this kind of question, you need to use partial fraction expansion to find the inverse Laplace transform. So this equation, this part, you can divide them into components in which it is equal to s minus 5 and s minus 2. Okay, so therefore the equation can be divided into two components, a over s minus 5 plus b minus divided by s minus 2. So you need to find what is a and what is b. Okay, so from the calculation, a equal to 5 over 3, while b equal to minus 2 over 3. So you put all the values into the equation. So now you already have the equation in shape. Then to get ft, so you need to compare the components with the table. So in which you will notice that these two components are in shape of this from the table, from Laplace transform table. So therefore, you can compare each individual component. So in this case, 1 over s minus 5. So in which it is equal to 1 over s plus minus 5. Therefore, you know your a equal to minus 5. Okay, for the first component, while in the second component, a equal to, so you can say that a1 equal to minus 5. So A2 for the second component, it is equal to minus 2. Okay, now let's write the equation for Ft. So Ft equal to 5 over 3. So 1 over s divided by s minus 5. So this is equal to E minus, so your E in this case is negative 5 TUT. Okay, so it is equal to E positive 5 TUT, while the second component is E negative 2 over 3 E minus your E is negative 2 TUT. So therefore, the complete equation or the inverse Laplace transform of Fs equal to Ft as the equation shown. Let's look at the third question. So given two signals xt and yt, then you need to determine Laplace transform for a new signal zt based on the following conditions. So obviously when you have a signal in time domain, to solve using Laplace transform, so you need to convert all signals into S domain. So you need to get what is your xs and also ys. Okay, let's look at this question. Determine the Laplace transform for zt for the following conditions. So the first condition, zt equal to xt plus yt. So you need to get zs. So in this case, again, refer to the table. So what types of equation you may have in S domain. So you may find that the addition between two signals will be having linearity process, so in which the addition of two signals will be the addition of two signals as well in S domain. So now you need to determine what is what is xs, so what is xs, and also what is ys. So again, refer to the table to convert each individual components into S domain. So you may find this equation. So for xt, you have the tut function, while the yt, you have the exponential function. So to start with, you know that your zs will be equal to xs plus ys. So what is your xs? So xt equal to t to the power of 1 ut. So you know from the table t to the power of n ut will be having n factorial divided by sn plus 1. Therefore, your xs equal to 1 factorial equal to 1 as 1 plus 1 equal to 2. So this is your xs. Xs from xt. So next, determine what is your ys from yt. So yt equal to the given equation. So e minus 5t ut. Okay, so compared to the equation from the table, so you know that e minus at ut will be producing 1 over s plus a. So now in this case, your a equal to positive 5. Therefore, so your ys equal to 1 over s, your a is positive 5, so plus 5. Okay, so you have both components in hand. So now you can calculate what is your zs. So zs equal to xs plus ys, in which it is equal to, so your xs is 1 over s squared plus ys is 1 over s plus 5. So this is your zs. Okay, let's look at the second part of the question. So you need to find the Laplace transform for zt. So in this case, you need to find what is your zs. Okay, so again, refer to Laplace transform table. So look at the function or operation involved. So in this case, you may notice that there's scaling and also shifting. So from the table, you may notice that it is basically a time transformation process. So next, you need to compare the given equation with the one you have from the table. So in this case, it is equal to f at minus t naught, in which it will produce 1 over a f s divided by a, e minus s t naught divided by a. So from here you can get your a. So in this case your a is equal to positive 2 and your t naught equal to positive 1. Okay, so now rewrite the equation. So we know that f, this is from Laplace transform table, f a t minus t naught ut minus t naught will produce 1 over a f s over a e minus s t naught over a. So from your equation, you have your zt equal to x 2t minus t naught, in which you'll produce 1 over a. So your a is positive 2. So x s divided by 2 multiply with e minus s t naught equal to positive 1. So 1s divided by a. So in this case, what is your xs? So xs from question 1, from 1, you know your xs equal to 1 over s squared. So now you need to replace xs into this equation, but take note that all s for x must be divided by 2. So therefore, your zs equal to 1 over 2 x s over 2 multiply with e minus s over 2. So your xs is 1 over 2, 1 over s squared. But all s must be divided by 2. So s divided by 2 squared multiply with the exponential function s over 2. Okay, so this is your zs. Okay, let's look at the first question. To write mathematical expression of signal xt. So as usual, you need to write the equation for the signal for, considering each of the t position. So you may see for straight line, you can put the arrows showing the direction of the signal from left to right. So at t equal to 0, so in this case xt equal to, at t equal to 0, you have one vertical line, so the magnitude is 2 ut minus 0, and then so this is pointing up, so it's plus, so here is negative, and another one is negative as well. So at t equal to 2, so minus the magnitude at t equal to 2 equal to 1 ut minus positive 2. So it is negative because it's pointing downward, and then at t equal to 3, so pointing downward again, so it's negative again, so magnitude is 1 ut minus 3. So this is your xt. So simplify the equation, so xt equal to 2ut minus ut minus 2 minus ut minus 3. Okay, so next question, sketch ht in time domain and obtains its Laplace transform hs. So ht is given by rectangular ut. So how this signal looks like? So for rectangular function, always remember the basic rectangular shape. So this is the fundamental rectangular shape. So magnitude is a. Here is negative 1 over 2, and here is negative 1 over 2, sorry, positive over 2 t. So the equation is a rectangular t over tau. Tau is the width of the rectangular. So in this case, compared to the given equation, so it's 1 rectangular t over 1. Therefore, you know the magnitude is 1. So, and then the tau, the width is 1 as well. So this is your rectangular t. So magnitude is 1, and then the width is 1. So it's negative half to positive half. So this is rectangular t. Okay, but ht is equal to rectangular t ut, meaning that this rectangular t multiply with ut. So ut have one positive amplitude at positive t, while negative t will be 0. So when you multiply these two signals, so you get rectangular t ut equal to only the positive side. So 1 over 2. So this is your ht. The magnitude is 1. So therefore this is your ht. Okay, but don't forget to look at the question completely. First, you need to sketch. Second, you need to obtain its Laplace transform. Okay, so next, to get the Laplace transform, so you need to have your ht equation first. So ht in this case equal to, it's pointing up and it's pointing down. So it's 1 ut minus 0, and then pointing down negative, the magnitude is 1 again, ut minus half. Therefore, your ht equal to ut minus half. So next, you need to get the Laplace transform of this equation. It is hs. So you need to refer to the table. So you have time shifting here. So as usual, when you have time shifting, it's t minus half. So your a equal to positive half. So it is equal to 1 over s e negative. So your a is positive half. So 1 over 2 s. Okay, so here your hs equal to ut. Ut is 1 over s minus ut minus half is 1 over s e minus s over 2. So this is your hs. Okay, let's move on to the third part of the question. So determine the mathematical expression of signal ys and zs. So you need to work out on the operations involved from the figure. So in this case, you know that yt, ys you get from yt. So you need to identify what is yt and also zt. Okay, so yt equal to xt convolve with ht. So refer to the tables. Supposedly, you know when there's convolution in t domain, in time domain. So in s domain, it will be multiplication of both xs and hs. So y s equal to xs multiplied with hs. So what is your xs? Xs is from question 1. Okay, so you know that your xt from question 1 equal to 2ut minus ut minus 2 minus ut minus 3. So you need to get your xs, in which it is equal to 2 over s minus 1 over s e minus 2s minus 1 over s e minus 3s. And what is your hs? Hs you have derived from question 2. So from question 2, this is from question 1, so this is from question 2. So hs is equal to 1 over s minus 1 over s e minus s over 2. Okay, so therefore your ys equal to xs multiplied with hs. So you need to multiply both signal in s domain. So therefore it is equal to 2 over s minus 1 over s e minus 2s minus 1 over s e minus 3s multiply with hs, 1 over s minus 1 over s e minus s over 2. So please expand the equation and solve for ys. Okay, from the third question just now, we haven't solved the zs. So let's look at zt equal to yt multiplied with sine 50t. So again, refer to the table. So you'll notice that modulation process. So compare the given equation with the one you have. So you have zt equal to yt sine 50t, in which zs equal to g over 2. So f becomes y, in this case y s plus g. What is your omega naught? So omega naught is 50. So g 50 minus y s minus g 50. Okay, so now your zs equal to g over 2 y s plus g 50 minus y s minus g 50. Okay, so what is your ys? Ys from, so both ys from previous slide. Okay, so you need to put in your ys equation, and don't forget the s for the y must be added by g05 50 and also deducted by g50. Okay, so please derive the equation by including ys that you have derived from earlier question. Okay, so next, based on your answer in 3, briefly discuss the process involved to obtain output zt. Okay, so obviously in the first part of the figure you have convolution. Okay, and the second part of the figure you have the modulation. Okay, so therefore you can answer to obtain set t, the input signal. So in this case, we have input xt, ht, and also sine 50. Experience, convolution, and modulation processes. Okay. All right. So that's all for this question. Okay, let's look at the last example for today. So solve a differential equation as the equation shown by using Laplace transform. So given the initial condition is v not equal to minus 5. So we know that when you have this prime, so it is basically equal to differentiation. So it is dv over dt minus 2v equal to e to the power of 3t. So prime meaning that you have single power. Okay, so let's derive the equation using Laplace transform. So in this case, don't forget to solve by components. So you have the first component, the second component, and you have inhomogeneous equation because it is not equal to 0. So you have the third component as well. Okay, so for the first component, so dv over dt. So since the power is 1, so your s is to the power of 1. So s to the power of 1, so vs minus no more s, so it's v0 for the first component, then minus the second component. So there's no prime, there's no differentiation, so it is equal to vs equal to the third component, e to the power of 3t. So refer to the table. So when you have e minus at ut, so it will produce 1 over s plus a. So in this case, you have e to the power of 3, so it's negative 3 t ut. So you know that your e is equal to negative 3, so 1 over s minus 3. So this is equal to 1 over s minus 3. Okay, so next step. So replace v naught equal to negative 5. So in this case, s vs minus v naught is negative 5 minus 2vs equal to 1 over s minus 3. So now you need to get the equation for vs. So vs in the bracket s minus 2 equal to 1 over s minus 3 minus 5. Okay, next what is vs? So vs equal to 1 over s minus 3 s minus 2 minus 5 multiplied with s minus 3. Okay, so this is equal to, so you can simplify the equation. So this is equal to minus 5s plus 15/16 divided by s minus 3 s minus 2. So when the question asks you to solve, meaning that you need to get until the inverse Laplace transform, the equation in t domain. So you need to perform partial fraction. So next you need to perform partial fraction expansion as the other example that we have discussed earlier, partial fraction to get what is a, b, and other parameters. And next you need to perform inverse Laplace transform. Then you get the equation in t. So you will get vt in this case. So for partial fraction expansion, so this is basically equal to a divided by s minus 3 plus b divided by s minus 2. So you need to find what is a and b, and then rewrite the equation by including both a and b values. Next, perform inverse Laplace transform for the given equation. So please derive and complete the solution, and you can compare with the previous example as reference. So with that, I'll end the session for today. So please refer to more examples. I'll be sharing more examples in the next file. Thank you.